Hello there, welcome back to another one of my videos. This is part 2 of Cooling Wars. Right, in this episode we're going to be discussing engine saturation, heat saturation. This has a massive effect on your engine because when you're touring over long distances, your engine gradually gets hotter and hotter and hotter, and that heat then goes straight the way through the engine. So the whole engine becomes extremely hot, and these temperatures can exceed 100 Celsius. And at that point, you're starting to look at having problems with certain things, and sometimes it can be electrics. So I've been looking into things on the internet because I know for a fact that hot engines are just less reliable. You have problems with engines when they're too hot. Not only does it sort of stretch bolts, make gaskets weep, and that's for obvious reasons. You overheat the engine, everything starts to get expanded and stretch bolts and stuff like that. But also that heat has an effect on your electrics. I've been looking online to try and find information on what kind of temperatures coils and windings and the lacquers that go over them, the coatings that are on them, can withstand. And old ones can fail much earlier, but even new stators can fail due to your engine having excessive heat. So I had a little chat with my friend Mr. Anthony Tams from Screwtronics. This is one of his stators. Very good indeed. And I would really recommend buying stuff from Anthony. His quality is very, very good. But, you know, when you're buying stuff for your bike, like stator plates or electrical equipment, well, basically anything, try to buy quality. Cutting corners doesn't always work. If you want to have a reliable engine, buy quality items that are put together better as well, because this is put together quality. So if you've ever had problems with electrical failures while you've been out on, riding around, and all of a sudden you start getting a misfire, it splutters, it stops, engine cuts out, and you've got no spark. And you're like, what the hell's going on? But then after a while, you cool the engine down and the spark comes back again. You're like, whoa, great, off we go again. Then it'll just stop again. That's because you've exceeded the temperature of the parts and they're starting to break down because the coatings in the small windings, especially in pickup coils, are really susceptible to heat. And the problem with stator plates is they're hidden inside the engine, so they've got absolutely no cooling. There's no airflow over it to keep it cool. On large bikes, say big Suzuki 750, you'll find that its stator plate is right inside the engine and it's got oil flowing around it. That keeps the stator plate cool. I wonder why they're more reliable. Ooh, engine temperature. So basically, keeping your overall engine temperature down is really important when it comes to reliability. The most of your heat is made by the cylinder head. So the middle of the cylinder head, let's just grab one. Standard style cylinder head. Most of the heat, obviously, is created here in the center of the dome and around the center. And then it's dispersed out. And the airflow that's coming over it is then taking away the heat. So radial heads work a little bit better because most of their fins are going to the centre of the head where the most heat is. But these cylinder heads, which is the original Lambretta design, have a little bit of a problem by the way the cylinder cowling's designed. Let's have a look. So as you can see, the cylinder shroud comes right up to this edge here, which is this one right here, and it covers in the whole of the top fins of your cylinder head. So it's stopping flow over the most important part, cylinder head. So it just beggars belief while nobody's telling everybody about this. I know there is a lot of people that have clocked onto it. That's why they're cutting their cowlings away or putting holes in to try and flow air over the top of the head. There are a few people sort of wising up to it, but they're not spreading the info out for your average Joe to understand what's going on. So That's there covering the top of the head like that and stopping the air from flowing over it and really screwing up your cooling. The first little modification you can easily do on a cylinder head cowling is to remove material here and cut it away. You can even go higher if you want to get a little bit more airflow over the cylinder head. That is really important. That makes a huge difference, because if the air can escape, it can then flow. If it can't escape, it's just backing up in there and getting super hot, and you wonder why Lambrettas overheat. Absolutely brilliant. ACF 50, what a product. It protects your bike winter and summer on all your mechanical parts. Go out, buy it, it's the best on the market. Okay, we're looking at engine heat saturation. So from the cylinder head, the heat then works its way down through your engine, starting to heat the whole casing up. So everything becomes hot. What I've done on my engine casing is I've popped on a couple of these Thermax surface temperature scales here. They change colour as it heats up. So I've popped one on various positions of my engine. I've been using them for a while. I've just put a new set on, and we can then monitor different parts of the engine of the temperature it's going to get to. The ones I've just took off, they didn't go past 88. My engine casing went up to 88 Celsius, which is pretty well respectable. So the engine really didn't get overheated. Most of my heat was taken away from my cooling. But it's really important having a cooler engine casing, because what people don't realise is part of your engine cooling is the fuel that's coming into your engine. The fuel and air that's coming through the carburetor, it goes directly down into behind the piston and round the casing inside here. Now, if your casing is very, very hot, you're going to start to lose performance. And the reason being is your fuel will vaporize when it hits the red hot casing. Well, it's not red hot, but it's hot. When that fuel hits your casing, the surface, it's vaporizing on that surface, okay? So you're then getting a weaker mixture. So you start to lose power and the engine starts to run even hotter. It's like thermal overload. When your engine gets to a certain temperature, it carries on increasing temperature because the cooling effect of your fuels coming in is having a negative effect because it's vaporizing on the casing because it's too hot, and therefore you're getting an even weaker mixture. The air's still going in, so the fuel's becoming less because it's being vaporized. Fuel has a massive, massive effect on engine temperature. Yeah, everything's just wrong. The whole design's wrong. But that's why you love them. Right, now let's discover another thing that is quite negative on Lambretta. The original position, this is the good part, of the carburetor is on this side of the engine, on the left hand side, which is okay. But when people decided to invent the TS1, they moved it over to the other side. Now, you've got a big reed block that's obstructing airflow. So the top half of the barrel is getting no airflow over it because your reed block's now obstructed airflow in this direction. That's a bad thing. And now any airflow that does come over this side is hitting the bottom of the float of the carburetor and heating the carb up. Let's just plop one in. Get in there. Right, so as you can see, air's passing over here and over these hot fins, all being blown in that direction, hitting the back of your float bowl. So if your cowling's cut away here, even the heat that's generated off the bottom of this cylinder here is right underneath the float bowl. when your fuel gets so hot, it starts to bubble up and vaporize inside the carb, and you just suddenly have a lack of power, and you'll go, what's going on? It's too hot. The fuel in your carburetor's too hot. You're just losing power, and you don't realize why. And I've come across these things over the years and learnt from my experiences. So you need to shield the bottom of your carb, your float bowl here, really important. I've sometimes used a little bib that goes over the back of it, that hangs down behind the carb with some insulating material like a rubber or whatever that you can go from behind it, or a dense foam that sits behind the float bowl here and protects it from the heat from the cylinder. Very important. Keep your carb cool, keep your fuel cool, better engine cooling, better performance. And here we are again with another thing that people seem to be doing, I seem to see quite often. Yes, I've had one of these heads and I've tried it and tested it in endurance racing, and it was worse than what I had before. Because as it's got more volume, but as it gets hotter, the volume makes no difference. It's the actual cooling area and the airflow over it. The problem was, when you fit one of these heads, your shroud has to pass over the head. So there, you've got now a massive gap around the barrel. So what happens is, the air simply flows through the huge gap and it never gets over the top of the head. So the head just keeps increasing in temperature and doesn't get any heat away. It's just a giant heat sink that ain't doing anything, because you need your cylinder head cover to run close to the fins to force air through between the fins, so taking heat away from the surface. If you've got a gap, air is flowing over and it's doing nothing. Nothing. This doesn't work unless you put it that way up and put a scoop on it. Then it'll work. That head will work then if it's getting airflow directly on it and flowing straight over it. But you stick it in a cover that's closed over it, and the air is hang on, I've got a cover somewhere. Well, I couldn't find a cover, but I've actually got a mould which is close enough. So we'll just drop this head inside, and now you can see the problem. There's hardly any space for the air to pass around the side of the cylinder head. So therefore, you ain't getting enough air over the head. So it's just simply flowing over the huge gap that you've got and escaping. This is the worst idea ever. You need to completely redesign the shroud. I made a bit of a cutaway in mine to try and increase some flow over it, but the other ones don't even have that. So you can chop away a load out of here to try and get airflow over. So I would, if you've got one of these heads on, I would chop as much out of here as you can to try and allow air to flow over the head. Then you've got to put some kind of stuffers in to push the air through the fins, and then force more air over the top of the cylinder head. Because if you don't put these stuffers in here to block this air off, it'll all just escape. So maybe that's helping a few people. Now I know I'm probably going to get some pushback on that one, where I've just been telling you that these big heads don't work. Big heads. Come what may. That's my opinion, and I know I'm absolutely right. So if your engine seizes up with one of these big cylinder heads on, take it back to the bloke that put it together for you and tell him he's done it wrong. Right, did I have my glasses on then? Oh, anyway, I'm going to have to take a little break because it's absolutely baking in my workshop at the moment, and I can't breathe. It's just ridiculous. Hang on, let's have a look. engine casing, 31.8. It's 32 degrees in here. No wonder I'm sweating. Right, we're going to have a tea break. See you in a bit. Okay, we're back. Got myself a beer out the fridge anyway, so that might help a little bit. So where were we? Where was we now? Right, yeah. You probably want figures now. I bet you're all saying, tell us some figures, tell us some figures. Right, went on the internet, and as far as I can work out, most of the information I got was looking at 140 Celsius is the safety point on electronics and electrical components. Anything over 140 Celsius and you're going to start having trouble. Why do you think they put fans in computer towers? You know, whirring around, blowing air over their electronic components. Because they get hot and then they pack up. So what do? We enclose it in a Carburetor body. Genius. So press the button. Hang on. If you've got an ignition coil, please put it in a position where it's getting airflow. Or mount an heatsink on it. Don't put it up where they're making all these brackets that fit all nice and heat. Let's hide it all up the top there. Thing is, that's where you're going to get all the heat accumulating up the top and overheat your coil, and then you break down and you have to push. So you want to keep the overall engine temperature nicely below 140, because 140, it's not about, oh, I'm not going to heat seats. It's not about that. It's about reliability, and it's about electrics getting too hot, or the engine casing getting too hot, stretching stuff, stretching bolts, gaskets start to leak, air leaks start to happen. Keep your engine cooler. I run my engine between 70 and 80 Celsius. That's with my sensor on the top of the spark plug. So if you've got your sensor under the spark plug, you're probably looking at about another 10 degrees on top. Not much, but I'm running between 70 degrees and 80 degrees Celsius. That keeps my engine really reliable, nice and reliable. My engine casing hasn't gone much over 88, so I know that my cylinder head temperature is pretty accurate. Because on a long run, that heat will transmit through the whole engine, but that engine hasn't got above 88 Celsius, because that's where my strip told me it was. So I know I'm safe, and that's why I'm having less problems with electrics. I'm having more reliable engine. I've got less leaks, less air leaks, less bolts coming loose, less stuff falling off, and it's all down to engine temperature. Right, as you can see, on this cowling, this is just a normal standard cowling, but it's got the centre cut out. This aids air into the flywheel. Any obstruction here in the middle of this, any sort of grill of any type, will reduce the amount of air you're pushing over the cylinder. Anybody that's putting some sort of patterned item over the front of there, they need kicking up the arse. So thanks everybody for tuning into this episode of Cooling Wars. Probably upset a few people again, but that's what I like to do.